Hello everybody, my name is Carsten Müller and my talk is about the analysis of player load in German elite beach handball. Beach handball has its origins in 1992 and is growing in popularity since then. The match time is reduced to 2 times 10 minutes. Athletes play barefoot on sand surface and on a field measuring 27 by 12 meters. Scoring, which depends on the type of goal throws and the possibility of repeatedly substituting players at any time, are just two examples of the modified rules compared to team handball. And this places new requirements on athletes and coaches in terms of physical demands, tactics, and designing appropriate training programs. In this respect, monitoring player load might assist practitioners and coaches by delivering important information on physical requirements. Load monitoring generally can be categorized as internal and external and receives growing interest to better understand the impact of workload on athletic performance, fatigue, or injury risk. External load refers to the physical work performed in training or competition. Among others, external load can be described as the distance covered, velocity generated, or jumps performed, just to name a few. To date, only few studies analyzed internal and external load in beach handball. For example, Puyo demonstrated that female and male athletes cover 1,118 meters and 1,235 meters on average during a single match, corresponding to a mean distance of 60 and 70 meters per minute. Velocity averaged 4 kilometers per hour and was slightly higher in male athletes. Furthermore, the authors depicted lower mean distances covered in the second half of the matches, which is in line with results by Sanchez, and this points to differences in terms of player load between beach handball and team handball, which actually is pretty obvious, but also between female and male players, between both halftimes, and even between youth and adult players. And this is what we were particularly looking for in this study. Hence, our objectives are first to describe player load in German elite beach handball players, and secondly, to analyze the effects of gender, halftime, and age on player load in beach handball. In this ongoing project, we analyzed data of 71 German beach handball players so far during official competitions. The mean age in our sample was 20 years, with a range of 15 to 34 years. 34 official games were analyzed during national tournaments, resulting in a total of 307 datasets. Subgroup analyses were performed by comparing player load in 16 female athletes below 18 years, in 20 males below 18 years, and in 35 males at least 18 years of age and older. And this allows for analysis of gender and age effects on player load. Additionally, both halftimes were analyzed with regards to changes in player load. Where previous studies primarily focused on global positioning systems, GPS, we relied on local positioning systems, LPS, which allows for capturing data at higher sampling rates for indoor and outdoor measurements and is supposed to be more accurately in detecting player position compared to GPS systems. The flip side of the coin, however, is that LPS is more time-consuming given the laborious setup of the anchor nodes and calibration procedures. So we equipped all players with catapult vector devices, which are fixed in a vest and worn on the upper back in order to reduce the impact placed on the athletes. Data analysis was performed using the software provided by the manufacturer, which is OpenField version 3.3, and allows for the analysis of a huge number of different variables and also provides a large variety of different reports. Here, using the preliminary dataset, we focused on positional data, particularly on total distance traveled during a game, on meterage per minute, as well as maximum and average velocity, all captured at a sample rate of 10 Hz. IMU data include the maximum acceleration, number of jumps, as well as the absolute number of changes of direction and changes of direction per minute played. Each of these captured at 100 Hz. Our statistical analyses were performed using SPSS. The results are presented as means and standard deviation, and we also performed generalized linear models for subgroup analyses with Bonferroni adjustments. The complete sample covered a mean distance of 778 meters per game. Below we can see that the distance traveled in both half times was close, with an average of 394 meters in the first half and 384 meters in the second one. The results for meterage per minute look pretty much the same, indicating that the results of total distance traveled are not affected by playing time, which, by the way, was comparable between both half times with 6 minutes 24 and 6 minutes 22 seconds. Mean meterage per minute was 65 meters for the whole sample. And here we see the data for maximum velocity on top of the slide and below for average velocity per game. Summarized, mean maximum velocity was 15.5 kilometers per hour and the average velocity was 3.9 kilometers per hour. Only modest differences were found when we compared data of the first half with the second one. Hence, and also as expected from a first glance at these data, we did not find a significant effect of time. In a second step, we looked for differences between females under 18 years, blue-colored, males under 18, green-colored, and males at least 18 years and older, which are presented in red color on this slide. Here we found a significant effect of group, so post-hoc tests with Bonferroni corrections were performed, and what we found was the distance traveled, meterage per minute, and maximum velocity were significantly higher in young males compared to females. In terms of age groups in male athletes, we found higher values in all variables for the younger players, with significant differences for meterage per minute and maximum velocity, but not for total distance covered. Finally, we looked for any group by time interactions, which would be present in case of substantial performance differences between both half times and for any of the subgroups. Here on top, the variables are presented for each subgroup and for both half times. However, no significant group by time interaction effects were found. On this slide, the bottom table shows the mean maximum acceleration, number of jumps, number of changes of direction, and the changes of direction per minute. Here we found a significant effect of time and therefore performed post-hoc tests. And these revealed a significantly lower number of changes of direction per minute during the second half of the games compared to the first half. However, the other variables did not differ significantly. And now, to cut it short, again we found a significant effect of group with higher maximum accelerations and number of jumps during a game for male players compared with females, which was irrespective of age. Yet, looking at these variables, no marked differences were found between the younger, green-colored, and the older male players, which are red-colored. On the other hand, looking at changes of direction in total and per minute, no differences were found between our subgroups. And finally, we look at maximum acceleration, the number of jumps and changes of direction, with pretty marked differences in the number of jumps between male and female players. In the upper right corner, we see a substantial drop in the number of changes of direction during the second half of the game. Remarkably, this occurred equally in all three groups. Finally, our analysis of IMU data did not reveal any group by time interaction effects. In summary, we found limited signs of reduced player performance with competition time. Changes of direction per minute was the only variable we examined in which a significant drop in player performance could be recognized when comparing both halftimes. Interestingly, this decline was equivalent for all three groups in our study and might therefore be interpreted as an indication of potential fatigue effects. In this regard, Our outcomes do not support previous results, in which a significant drop in total distance covered was found in the second half of women beach handball. It has to be noted that in the study by Sanchez and colleagues, total distance covered was approximately 900 meters on average compared to 730 meters in our dataset. Secondly, our results indicate that gender and age do seem to play an important role regarding player load in beach handball. With exception of the number of jumps per game, younger male players outperformed female athletes of the same age, which we expected, but also outperformed older players. This supports previous studies in elite beach handball, which demonstrated gender differences and therefore the need for individualized physical conditioning. Yet, whether the difference between younger and older players is an indication of higher physical performance in younger players, or maybe just an endeavor to compensate for techno-tactical deficits, must remain open at this point. Yet it is notable that younger players generally performed high in the first half and were able to confirm the above average performance in the second half as well. And that's it. So thank you very much for listening, and of course a big thank you goes to the Federal Institute of Sports Sciences for funding.